of A and B is always related to A. Ring sum of A and B, it is again related to B also, that we can see by the definition. Now we are going to see some certain properties of meet and join. Obviously we consider L together with less or equal is a lattice, and A, B, C are any three members taken from L. So we will have some certain elementary laws. First is the idempotent law. Idempotent law we can see here. Idempotent law. Idempotent property is the property of element with itself. Idempotent law. Let's consider A from L. A is any member of L. Now what do you mean by A star A? A star A means the greatest lower bound of A and A. Obviously A and A is a single member in a set, so that the greatest lower bound is definitely A. Similar fashion, the ring sum of A and B means the least upper bound of A and B, A and A, so that it is also A. So it is very clear by the definition. Now we can consider the another law, that is the commutative law. We are going to prove commutative law, or you can say Abelian law. Consider any two members from L. We are going to find the A star B. A star B means what? Greatest lower bound of A and B. We can consider that as the greatest lower bound of B and A. It is same, so that it is to be B star A. So A star B is same as B star A. Similar fashion, you can check that A ring sum B, ring sum of A with B, it is also same with B ring sum A. By the definition, the least upper bound of A and B is same as the least upper bound of B and A. Similarly, we can also consider the associative laws. Associative laws, we are going to see associative laws. Associative laws. We are going to prove one laws. The first one is to prove. We can consider the association of A with B together and C alone, that is equals A star. We are going to consider the association of B with C. First of all, we call the left hand side as a X and right hand side as a Y. So it is very clear that X is, what is X? Is A star B star C. And what is Y? Y is very clear. It is A star into the bracket B star C. So that our intent is to show X is equals Y, and for that it is enough to show X is related to Y and Y is related to X. And now the relation less or equal is antisymmetric, so that X is same with Y, and for that we are going to prove X is related to Y. Now we know the X is A star B star C, and Y is A star into the bracket B star C. Now X is a A star B star C, means X is what? X is the greatest lower bound. X is the GLB of A star B and C. X is the greatest lower bound. So it is very clear that X is related to A star B. X is related to C also. So that X must be related to A, X must be related to B, X must be related to C. So we can see that X is related to A, X is related to B star C. So by the definition, it is clear that X is the lower bound of the set together with A and B star C, that we can see this. Now what is y? Look at here y. Y is the A star into the bracket B star C. So that y is the greatest lower bound of the set A and B star C. So any lower bound will be less or equal the greatest lower bound. So it is very clear that x must be related to y. Similar fashion, we can prove that y is also related to x similarly, so that by anti-symmetry we will get x is equals y. So in this sense we can also prove the results regarding ring sum. Now there is one another law, that is a absorption law. We are going to see this, the absorption laws. We are going to prove the one absorption laws to prove. What is our intent is to prove A star A ring sum B. A star A ring sum B, that is A. By the definition of star, it is very clear that A star B is always related to A. So that A star instead of B, we will have here A ring sum B. So it is always related to A. Let's consider that as equation number 1. Now, by the definition of relation or reflexivity, it is very clear that A is related to A. A is always related to A, and A will also related to A ring sum B by the definition of ring sum. So it is very clear that A is related to A as well as A ring sum B. So A will be the lower bound of the set consisting of A and A ring sum B. So it is very clear that A is related to A star A ring sum B. Consider that as number 2. Look at here 1 and 2. We can see that A star, the left hand side is related to right hand side and the right hand side is related to left hand side. So we are going to conclude that from that to 1, A star A ring sum B, it is same with A. Now there is one another rule. We can see here the second rule, A ring sum A star B, that is also A. By the definition of ring sum, it is very clear that A is always related to A ring sum A star B. So it is enough to prove A ring sum A star B is related to A. Now A is always related to A by the reflexivity, and similarly by definition of star, it is also clear that A star B is related to A, so that A will be an upper bound of the set consisting of A and A ring sum B. So that it is very clear that A ring sum A star B is related to A and A is related to A ring sum A star B, and by the anti-symmetry the results is there, A ring sum A star B, that is equals A. So these are the very basic rules regarding lattice. Now we can also see the lattice as an algebraic structure. For example, you know about algebraic structure. Let us consider any non-empty set. If there is at least one binary operation defined on that set, then the set that L together with that relation will be an algebraic structure. We are going to define two binary operations, namely star and ring sum on L. And the set L together with star and ring sum is said to be lattice if the condition number 1, which says that star and ring sum are commutative. The first property is that star and ring sum are commutative. The second one is that star and ring sum are associative. If star and ring sum are associative, the third property is that star and ring sum satisfy absorption laws. As we will have already seen in our previous slide, absorption laws, that we can see this. Then the then the set L together with that two relations star and ring sum, it is said to be lattice as an algebraic structure. So we can also see some certain examples of a lattice as an algebraic structure. So we can consider here the S6. We will have already seen in previous slide 1, 2, 3 and 6. We can see here we are going to define A star B means GCD of A and B. We are going to define here A ring sum B means LCM of A and B. So we can able to draw the table for star and ring sum, and we can easily check that star and ring sum both are the commutative binary operations. Similarly, star and ring sum are associative as well as they satisfies law of absorptions. So we can see that the S6 together with that two relations star and ring sum will be a lattice. Similar fashion, we can consider any example Sn. N is the natural number. Sn together with star and ring sum, where star and ring sum are the GCD and LCM of any two members respectively. We can see that the set Sn together with that two relations star and ring sum will be a lattice. Thank you. Thank you.
SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.